You've probably heard the term quantum computing thrown around, and right away, you might picture something straight out of science fiction. But let's push the sci-fi side for a minute. What's really happening is a global race to solve problems we currently think are, well, unsolvable. So what does this new era of computing actually mean for us? Let's dive in.
So, is this thing just a ridiculously fast version of the computer on your desk? Or is it something else entirely, a completely new way of thinking? The real question here isn't just about getting answers faster. It's about getting answers to questions we couldn't even ask before.
And to get our heads around that, we first have to understand what the goal even is. We're going on a hunt for what's called the quantum promise. We're trying to find that point where this amazing technology finally leaves the laboratory and actually starts changing our world.
And here's what's so cool. This isn't just some abstract academic thought experiment. The ultimate prize here is all about practical, real-world impact. I mean, imagine being able to design a new drug, molecule by molecule, to wipe out a disease. Or creating a new material that lets our phone batteries last for weeks instead of hours. That's the kind of world-changing power we're trying to unlock.
Okay, so if the promise is that big, why aren't these quantum machines everywhere already? Well, it's because the path to actually building one is, famously, incredibly difficult. And the reason why is that it's not just one hard problem, it's basically 3 of the hardest challenges in science all smashed together.
So here's the absolute crux of it. Quantum computing is so tough because it sits right at the intersection of 3 hugely complex fields of human knowledge. You can't master one without the others. It's a true triple threat.
Okay, so first up, you've got the physics. You literally have to harness the bizarre, almost magical rules of subatomic particles. Think about it like this. A normal computer bit is like a light switch, right? It's either on or it's off. Simple. A quantum bit or qubit can be both on and off at the exact same time. It can explore millions of possibilities at once. Then there's computer science. You can't just run your old software on these things. Nope. You have to invent entirely new kinds of algorithms from the ground up. And finally, the mathematics. You need a whole new, deeply complex language to even describe and control what's happening. I mean, mastering just one of these fields is a life's work. To build a quantum computer, you have to master all 3 at once.
So, when you're facing a challenge that massive, how do you even measure your progress? Well, you do what any smart researcher would do. You narrow your focus. You create a specific contest, an arena, to see if these new quantum ideas actually have a real advantage.
And really, what better opponent could you pick than the reigning champion of modern computation? That's right. One of the most important research areas right now is putting these new quantum methods into a head-to-head showdown with the most powerful tool we have, artificial intelligence. It's the ultimate test.
So, in one corner, you've got the challenger, quantum algorithms. These are brand new ways to solve problems, built on the weird, counterintuitive logic of quantum physics. And in the other corner, you have the champ, classical AI models. We're talking about the sophisticated, powerful learning algorithms that are already running everything from your smartphone to the world's biggest supercomputers.
And this all boils down to one single, incredibly important question. A question that is driving millions of dollars in research and countless hours in the lab. Can these new quantum algorithms actually beat our best AI models on a really meaningful problem? The answer could honestly change everything.
But look, answering this question isn't just about picking a winner in a single fight. It's about what comes after the fight is over. It gives us a real glimpse into computing's next great frontier. You see, proving that a quantum computer can beat our very best AI at a useful task, that's a monumental first step. It would be the ultimate proof of concept. It would validate this entire massive effort, and it would give us a roadmap for unlocking the true practical power of these incredible machines. It's the key that finally opens the door to this new era.
And that leaves us with a final, really fascinating thought. This whole contest with AI, it's just one of the first big tests. So if we can solve this, if quantum machines can really prove their worth in this arena, it just makes you wonder, what other monumental, world-changing challenges could we finally take on? What problems that we think of as impossible today will suddenly be within our reach? Now that is the real promise we're all chasing.